All right, let's dive right in. We're going to pull back the curtain on large language models, LLMs, and really get to the heart of how to talk to them. See, there's a secret, a fundamental principle behind how all of this works. And by the end of this, you're going to have that secret. You'll get not just what they do, but how they think, and most importantly, how you can get seriously good at communicating with them. Let's do it.
I want you to imagine something with me. Picture this. You sit down at your computer to write a pretty complicated piece of software, but you're going to do it in a programming language you have never, ever seen before. Sounds completely impossible, right? You'd think it would be a total nightmare. But what if it wasn't?
And look, this isn't some hypothetical. This actually happened to John Berryman, who co-authored the book we're talking about today. He was trying to code in Rust, a language he knew nothing about. He just wrote a simple comment in plain English describing what he wanted to do. And his AI assistant, Copilot, just did it. It spat out 30 lines of complex code. He said you can literally hear him gasp on the recording. In just 40 minutes, he did something that might have taken a human expert hours, maybe even days. He did the impossible.
So, yeah, that leads to the big question, doesn't it? How on earth is that possible? Is the AI actually thinking? Is it reasoning things out like a person does? Or is there something else, something totally different going on under the hood?
Well, the answer? The real secret to all of this is actually surprisingly simple. It's not about thinking. It's not about understanding in the human sense. It all boils down to one single concept: completion.
And this is it. You have to wrap your head around this one thing. At their absolute core, LLMs are just incredibly sophisticated text completion engines. Seriously, think of it like the autocomplete on your phone, but just scaled up to a mind-boggling degree. After seeing a huge chunk of the internet, they've just gotten unbelievably good at recognizing statistical patterns in language. Their one and only job is to ask, okay, based on everything I've seen so far, what's the most probable thing that comes next? That's it.
Let's walk through a super simple example. Say you give an AI this prompt. Yesterday, my TV stopped working. Now I can't turn it on at... What comes next? I mean, sure, it could be a random jumble of letters if a cat walked across the keyboard, but the model has seen billions of sentences. It knows, statistically, that the most likely thing to follow that phrase is the word all. It doesn't understand your TV is broken. It's just finishing a pattern it's seen a million times before.
Okay, so they're completion engines. Got it. But how does that simple idea lead to writing 30 lines of perfect Rust code? How does that process actually work? Let's peel back another layer here.
First off, and this is so important, LLMs don't see words the way we do. They see things called tokens. A token is just a chunk of text, usually a few characters. Now you might be wondering why this matters. Well, look at this. The first sentence has scrambled letters inside the words, but you can probably still read it, right? Because our brains see whole words. But the second sentence, where the words themselves are all jumbled up, it's complete nonsense. LLMs operate in that second world, a world of tokens, not words.
So how does it build a response from these tokens? It doesn't just generate the whole thing at once. It actually builds it one tiny piece at a time. It's a simple loop. First, it takes your prompt. Then it predicts just the single next most likely token. It sticks that token onto the end of the prompt, creating a new, slightly longer text. And then it just does it again, and again, and again, predicting one token at a time until the response is complete.
But wait a minute. If it's always just picking the single most probable token, wouldn't every answer be exactly the same and kind of boring? Well, not exactly. We have a knob we can turn called temperature. Think of it like a creativity dial. If you set the temperature low, you're forcing the model to be safe, to pick the most obvious, correct token every time. The answers will be accurate and repeatable, but not very creative. But if you crank that temperature up, you allow it to pick some less likely tokens. Things get more random, more creative, maybe even surprising. But also, you run a higher risk of it being just plain wrong. So we have this unbelievably powerful token predicting machine. That's cool. But how do we get from that raw ability to just complete any document to the helpful, friendly assistants like ChatGPT or Claude that we actually talk to every day?
Well, for one thing, the scale has just exploded. I mean, look at this. In 2018, GPT-1 had 117 million parameters. Think of those as the connections the model uses to learn patterns. A year later, GPT-2 had 1.5 billion. Then just 1 year after that, GPT-3 came along with a staggering 175 billion. With every one of these massive leaps in size, new and totally unexpected abilities just emerged. But scale isn't the whole story. It doesn't automatically create a helpful assistant. Just look at the difference here. If you give a raw base model a question like, what is a good dish for chicken, it just sees a pattern. So it completes the pattern by writing more questions. But a chat model that's been fine-tuned, it actually answers you. It understands the assignment. So what's the secret ingredient that causes that change?
That transformation comes from a special training process with a long name, reinforcement learning from human feedback, or RLHF. Basically, after the model is first built, real humans come in. They look at thousands of different answers the AI gives, and they rank them, telling it this is a good answer, this one is bad, this one is better. It's this process of feedback and fine-tuning that teaches the model to stop just completing patterns and start being helpful, honest, and harmless. It's what turns a raw engine into a real assistant.
Okay, so now we know the secret. LLMs are document completion engines that are fine-tuned to be helpful. So, how do we use that knowledge to our advantage? How do we get them to do what we actually want? This, my friends, is the art and science of prompt engineering. And the book gives us this fantastic mental model for it. It's called the Little Red Riding Hood principle. And the idea is just so simple. Don't stray from the path. Remember, the AI was trained on billions of real-world documents, things like reports, Q&A sections, code files, articles. The more your prompt looks and feels like one of those familiar documents, the better the AI will be at completing it in a way that makes sense. So what does staying on the path actually look like? Well, it's pretty straightforward. First, try to make your prompt look like a document type it knows, like a Q&A. Use clear structure, like headings. Give it all the background information and context it needs to do the job right up front. And this is a big one. Make it super obvious where you want its answer to begin. But getting good at this isn't just about writing one perfect question to get one perfect answer. The real power, the real magic, happens when we stop thinking about single prompts and start thinking about building entire systems with prompts. And this is the point I really want to drive home. Prompt engineering is not just a clever trick. It's the fundamental skill for building a whole new generation of software. The LLM is the engine at the core, and the prompt engineer is the architect, the one who designs how the user, the app, and the AI all talk to each other to get things done. So what kind of stuff are we talking about? Think bigger than just a chatbot. We're talking about building agents that can actually remember your previous conversations and learn from them. You can design workflows where the AI takes a massive goal, like plan my company's next marketing campaign, and breaks it down into smaller, manageable tasks. You can even build agents that can use tools, giving them the ability to search the live web or access other software to accomplish real-world tasks. So, there you have it. The secret's out. These AIs are incredibly powerful, token-by-token completion engines that have been carefully trained to be helpful assistants. And prompt engineering, understanding how to talk to them, is the key that unlocks all of that potential. It effectively turns you from just a user into a creator. It's your new superpower. So the only question left is, how are you going to use it?